folks. Welcome to
Vector Calculus.
Alright folks, welcome back to the next lecture in Vector Calculus. Today I want to show you how to find the direction of a vector, and we're going to take a look at a practice problem. Let's go ahead and check it out. Okay folks, so let's go ahead and check out our problem. We have a vector that has a size of 3 and it makes an angle pi over 6 with the positive x-axis. Our goal is to write our vector v as a linear combination of the unit vector on the x-axis, I hat, and the unit vector on the y-axis, j hat. Okay. Now, the first thing you want to do, first thing in any one of these vector calculus problems, is draw a picture. Okay, so let's go ahead and draw the coordinate plane. Okay, so let's go ahead, start by drawing the coordinate plane on the left hand side. So we have our vector of length 3. So let's go ahead and draw our vector in orange, and here's our vector in orange, and it's gonna make a certain degree with the x-axis, right? And the degree is gonna be pi over 6 radians. Or if you convert that to degrees, what's that going to be? Well, pi over 6 times 180 over pi is going to give you 30 degrees, right? So our angle is going to be 30 degrees. Okay, good. So we have our vector v that makes an angle 30 degrees with the positive x-axis. Our goal is to write our vector as a linear combination of I hat and j hat, knowing that the length of our vector is 3. So how do we do that? Well, remember, if you recall, we can use the trigonometric functions to find what the x component of our vector is, which I've shown in red, and the y component of our vector, which I've shown in green. So we can find vy, which is the y component of our vector, the vertical component, and we can find vx, the horizontal component that goes this way. So how do we find the, first of all, the horizontal component? Well, vx is going to be the length of our vector, 3, but be careful. Now we have to use a trigonometric function. And what function are we going to use? Well, check it out. I'm going to be using cosine. So if I say cosine of 30 is going to be adjacent, which is the horizontal component, over the hypotenuse, which is 3. So that tells me my horizontal component is going to be 3 cosine 30. And of course, hopefully you know what cosine of 30 is. That's going to be square root of 3 over 2. Okay, and with that being said, we're left with the x component as 3 root 3 over 2. Now what about the y component of our vector? How do you find the y component? Well, hopefully you figured it out. If I used cosine 30 for the x component, I'm going to have to use sine of 30 for the y component. And why is that? Well, what does sine of 30 give me? Sine of 30 gives me opposite, which is the vertical component, vy, over hypotenuse being 3. So that means my vertical component vy is going to be 3 sine 30. And of course, sine 30 is a half. So you're left with the vertical component as 3 over 2. Okay, so we have the horizontal component of our vector, vx, and the vertical component of our vector, which is vy. Our horizontal component is 3 root 3 over 2. Our vertical component is 3 over 2. Now, how do we express the horizontal and the vertical component as a linear combination of I hat and j hat? Right? If you really want me to color code it for you, I hat can be in red because it's the unit vector in the x direction, the horizontal direction. J hat can be in green because it's the unit vector in the vertical direction, the y direction. Okay, well, it's actually not too bad. I can say that my vector v, which I'll write over here, is going to be what? It's going to be 3 root 3 over 2 of my I hat vector. So 3 root 3 over 2 of I hat plus what? Plus how much of j hat? Well, you can clearly see 3 halves of j hat. So 3 over 2 of j hat. And that, ladies and gentlemen, is how you express the vector v over here as a linear combination. And that's how you find the linear combination of a vector just by its magnitude and direction. And we'll check you out in the next lecture of vector calculus.